This PowerPoint is on Chapter 6. And in Chapter 6, we look at the what-if analysis. We look at using decision-making tools in Excel. So first, we're going to start with range names, the most basic thing. So a range name is a word or a string of characters assigned to one or more cells. So instead of using the function like PMT with cell references B3, C3, and then minus D3, we're going to use range names to modify the function to PMT, periodic rate, payments, cost. Okay, range names are absolute references, which helps to ensure accuracy in your calculations. We're going to learn how to create and maintain range names. Each range name within a workbook must be unique. For example, you can't assign the name cost to ranges on several worksheets or even on the same sheet. After you create a range name, you may edit its name or range if a change is required. And if you no longer need a range name after using it, you can delete it. You can also insert in the workbook a list of range names and their respective cell ranges for reference. So, in terms of creating a range name, what you need to remember is that a range name can contain up to 255 characters, but it must always begin with a letter or an underscore. Okay. You can use a combination of upper and lower cases, numbers, periods, and underscores throughout the range name. Okay, but make sure of this that you do not include spaces, so no spaces, and you don't have special characters. So other than the underscore and the period, you cannot have any special characters. It must be all letters or numbers. Okay, no spaces especially. You should create range names that describe the range of cells being named. Okay, so it should be descriptive, properly named. Okay, so names cannot be identical to the cell contents. Remember that. Keep the range names short to make them easier to use in formulas. So although a range name can contain up to 255 characters, you don't need to make it long. Make it as short as possible. Next is acceptable and unacceptable range names. So here we have a list of an example. So grades, that's an acceptable. It has uppercase, that's fine, and all lowercase, all letters. COL, okay, acceptable abbreviation for cost of living. So still descriptive if that's a known abbreviation. Tax rate, acceptable name. There are two words and they're joined by an underscore, not a space, okay, and not any other special characters, not a hyphen. Okay, so an underscore. Commission rate, not acceptable, unacceptable. It's using a space, so no. Discount rate, again, it's using special character percentage here and also spaces, just bad. And 2018 rate, no, not acceptable because it starts with a number. You must start with a letter or an underscore. Rate underscore 2018, so this will work. It starts with a letter, has an uppercase, that's fine. Has an underscore instead of a space, and has numbers at the end. You can use numbers, you just can't use it in the beginning. All right, so now you're ready to watch the tutorial videos. In a tutorial video, you'll learn how to create a range name, edit or delete a range name, use range names in formulas, and how to insert a list of range names. So I would like you to please pause this PowerPoint video for a while. Go to your tutorial videos and watch the tutorial videos on range names, and then you may come back and continue watching the rest of the PowerPoint. Now, the next section that we're going to look at, let's talk about what-if analysis first. So what-if analysis enables you to experiment with different variables or assumptions so that you can observe and compare how these changes affect a related outcome. So a variable is an input value that can change to other variables that affect the results of a situation. So people in almost every industries, they perform some type of what-if analysis to make informed decisions, right? So remember that these what-if analysis tools are just that, they're tools. These tools don't provide the definitive perfect solution to a problem. They just help you analyze and read the data, interpret the data. Okay, so it still takes a human to make the ultimate decisions based on the data. So it doesn't think for you. It interprets the data for you, and you still have to make that decision. Okay, so here you're going to learn how to create a one variable data table and a two variable data table to perform the what if analysis. So our learning objectives for this section is to design the data tables, insert formulas, and complete the data tables to compare the results for different values of the variables. We're going to begin with the one variable data table. The one variable data table is a structured range that contains different values for one variable to compare how the different values affect one or more calculated results. For example, you can use it to compare monthly payments on a mortgage. Okay, so holding the payment periods and the loan amount constant the same, you can compare how different values of the interest rate, which is the variable because this is the one that's going to change, can affect the calculated results such as the monthly payment, the total amount to repay the loan, and the total interest paid. So how to set up a one variable data table. When setting up a one variable data table, you must decide which one variable you want to use, which is the one that is going to change. After you've decided on an input variable, then you must select one or more formulas that depend on that input variable for calculations, such as repaying the loan and interest, total interest paid. Okay, so you have to set up a one variable substitution value. So after determining which is the value, which is the variable you want to manipulate, you need to specify the substitution values. So you need to specify which are the values that you're going to put into this variable. A substitution value is the value that replaces the original input value of a variable in a data table. So for example, if the original interest rate is 4.5%, but you want to see what, the whole, what everything's going to look like with 5% or 5.5% or 6% or 6.5%. So you have to put those numbers now, those percentages now in place of the 4.5, the original amount, original percentage, to see how the different interest rates affect the results. So you can enter the substitution values yourself. You can just type it in yourself, or you can use a series dialog box to complete a series of values. This will help you enter it more quickly, especially if you are going to have like 50 substitution values. You don't want to type it all in yourself. Okay. Next, you are going to then add formulas to the one variable data table. After you have inserted the substitution values, you're going to add the formulas. After you enter the substitution values, in this case, the different percentages, then you must add one or more formulas that relate mathematically to the variable that you're using for substitution value. So it must relate to that substitution value, that variable. So instead of creating formulas in the data table, reference cells containing the existing formulas outside of the data table. So don't type in the formulas yourself. Reference the cells that are containing these formulas. Because this saves time and reduces errors when you reference the original formula. The formula references must be entered in specific location based on the location of the substitution values. Okay. Next, you're going to calculate results, and then you're going to format the one variable data table. So I would like you to please watch the tutorial videos now. Watch it on setting up a one variable data table. I would like you to please pause this video right now so you can watch your tutorial videos, and after that you can come back to this. All right, so the next is to create a two variable data table. Okay, in the last tutorial, last slide, we looked at one variable. Now we're going to look at two variables. So although one variable data table is effective for comparing results for different values of one input, you might want to compare results of a calculation based on two variables. So a two variable table is a structured range that contains different values for two variables to compare how these differing values can affect the results for one calculated value. So basically, you're looking at how changes in two variable inputs are going to impact the final value of the calculation. So it is used to compare the combined effects of various interest rates and also different down payment amounts on the monthly payment. So you're not just looking at the effects of the interest rates, you're looking at the effects of interest rates and different down payment amounts, okay? So remember that it can only be one result. The two variable data table enables you to use two variables, but you're restricted to only one result instead of multiple results. So you'll only be able to look at monthly payments instead of a whole bunch of different results. Okay, so with the one variable data table, you use the interest rate variable to compare multiple results like monthly payment, total to repay the loan, and total interest paid. You were able to look at three things. But with the two variable data table, you can only look at one, such as the monthly payment maybe. All right, so now you can watch the tutorial video on creating a two variable data table. You learn how to add a formula to the data table and calculate results for the two variable data table. So please pause this PowerPoint video right now and go to your tutorial video and come back to it. Come back to this when you are done. The next section, we are going to look at goal seek and scenario manager. So data tables are useful to compare the effects of different values for one or two variables. Other what-if analysis tools like goal seek and scenario manager are better suited in other situations. For example, you might want to use goal seek to determine exactly what the down payment required to acquire a desired payment is. So in this situation, you wouldn't need all the data provided by the data table. You may also want to weigh the options between various values of down payments, purchase costs, and interest rates. So you can use the scenario manager for this. If more than two variables are required, then data tables would not be a viable option. The data table you can only do one variable or two variable data table. If you need more than two, then maybe you should look at goal seek or scenario manager. So you're going to learn when and how both the goal seek and scenario manager can assist you in making decisions. These tools will enable you to perform what-if analysis to make forecasts or make predictions involving quantifiable data. So determining optimal input values using goal seek. So suppose the most you can afford for a monthly payment on a mortgage is $800. So how can you determine that the down payment amount needed to meet that monthly payment? Goal seek is a tool that allows you to specify a desired result from a formula, so the $800 monthly payment, without knowing what input value achieves that goal. So goal seek kind of works backwards to identify the exact value for a variable to reach your goal. You can use goal seek to determine the required down payment. So unlike variable data tables, goal seek uses the original worksheet data to change an input instead of displaying various combinations of results in a separate table. So I repeat, so it actually changes an input in the original worksheet data. So it actually changes the data in like the original data. Okay, it doesn't display it in a separate table. Okay, it's not a data table. So goal seek manipulates only one variable and one result, and it does not produce a list of values to compare. So I would like you to pause this PowerPoint video again, and please watch the video tutorial on goal seek. Next, we look at the scenario manager. You might want to compare several variables and their combined effects on multiple calculated results. So this type of analysis involves identifying and setting up scenarios, which are detailed sets of values that represent different possible situations. So business managers often create a best case scenario, worst case scenario, and most likely scenario to compare the outcomes. For example, a best case scenario could reflect an increase in units sold and lower production costs, so the best that could happen. A worst case scenario could reflect the fewer units sold and higher production costs. Okay. So a scenario manager is a what-if analysis tool that enables you to define and manage up to 32 scenarios to compare their effects on calculated results. You can perform a more sophisticated what-if analysis with scenario manager with an increased number of variables and results as compared to data tables. Okay, you don't get to play with as many variables. So the Scenario Manager dialog box enables you to create, edit, and delete scenario names. Each scenario then represents different sets of what-if conditions to assess the outcome of the spreadsheet model. So each scenario is stored under its own name and defines cells whose values change from scenario to scenario. So before you start the Scenario Manager, identify the cells that contain the variables that you want to change or manipulate. For example, when you're looking at home loans, you might want to manipulate the values for cost, down payment, interest rate, and duration of the loan. You enter the cell references for these variables as the changing cells. These are the ones that are going to change, okay, because you want to change these values to compare the results. After identifying the variables that you want to change, identify one or more cells containing formulas that generate results that you want to compare. Note that these formulas must be directly impacted by the changing cells. Okay, must have a relationship with them. All right, at this point, you're ready to watch the tutorial video and use the Scenario Manager. Please pause this PowerPoint video and go to your video tutorial and then come back when you're done. Next, we are going to talk about generating a scenario summary report. Although you can view the defined values and the results individually, you probably want to compare all the scenarios in the table. So a scenario summary report is an organized, structured table of scenarios, their input values, and their respective results. The summary report displays in the form of a worksheet outline, and it lets you compare the results based on different values specified by the respective scenarios. The scenario summary and scenario pivot table report. So Excel can produce two types of reports, the scenario summary and scenario pivot table report. The pivot table reports summarize the data in the pivot table, of course, and this provides the same functionality as any other pivot table. The scenario summary reports display the results of each scenario in a new worksheet. So the data reported in the summary are formatted without grid lines, and the report is easily printable. All right, so I'd like you to watch the tutorial video on how to create a scenario summary report. Next, we are looking at the last section of this chapter, which is the solver. So before you use the solver, you have to add an add-in. So what are add-ins? Add-ins are programs that can be added to Excel to provide enhanced functionality. Okay, so it adds more features, more functionality to the basic Excel that you have. A solver is one of the many add-in applications. Okay, and this application searches for the best or optimum solution to a problem by manipulating the values for several variables within restrictions that you impose. So you can add constraints in a solver. You can also use solver to create optimization models. Optimization models find the highest, lowest, or exact value for one particular result by adjusting values of the selected variable. So solver is one of the most sophisticated what-if analysis tools, and people use solver in a variety of situation industries. For example, a cell phone manufacturing facility might use solver to maximize the number of phones made or to minimize the number of labor hours required while conforming to other production specifications. Another example given by the textbook is that a financial planner might use solver to help a family adjust to its expenses to stay within the monthly income. Right, so optimizing results for the solver. A solver may be the best what-if analysis tool to solve complex linear and non-linear problems. You can use it for complex equation solving for constraint optimization, where you have a set of constraints that specify and you want the outcome to be minimized or maximized. Okay, with the solver, you're able to change the values of several variables at once to achieve the desired result. For example, business analysis might use solver to maximize profits by changing selected variables while adhering to required limitations, or a fulfillment company might want to determine the lowest shipping costs to transfer merchandise from a distribution center to retail stores. First, you have to, again, identify the objective cell and the changing cells. So before you use Solver, review your spreadsheet as you specify your goal. Think about what it is you're trying to do. Identify one or more variables that can change to reach the desired goal, and determine the limitations of the model. So again, the objective cell, like we did, the changing cells, which one changes, and then the constraints. What are your limitations? You use these data to specify these three parameters. Again, objective cell, changing cells, and constraints. Okay, so what's the objective cell? The objective cell specifies a cell that contains the formula that produces a value that you want to optimize by manipulating the values of one or more variables. So the formula in the objective cells relates directly or indirectly to the changing cells and constraints. So using the mortgage case study, the objective cell is the one containing the total interest paid formula. And then your goal might be to maximize the total interest. Okay, so now let's look at the changing variable cells. The changing variable cells are the cells containing variables whose values change with the constraints until the objective cell reaches the optimum value. So the changing variable cells typically contain values, not formulas, but these cells have a mathematical relationship to the formula in the objective. In the home loan example, the changing variable cells are B3, the down payment, and B5, the number of years, right? You can actually select up to 200 changing variable cells. Okay, we won't be doing that in this in our class exercise, but just note that the potential and how powerful this add-in is. 200 variable cells. All right, next, let's talk about defining constraints. The constraints specify the restrictions or limitations imposed on a spreadsheet model as the solver determines the optimum value for the objective cell. So rules govern every business model, right, based on historical requirements, physical limitations, and other decisions. So the most challenging process in using the solver is actually identify all these legitimate limitations. So what are the constraints? These are things that the Excel can't do. It can compute it for you, but it can't pick out the constraints for you. It doesn't know. You're the human, and you're the one that has to figure out what the constraints are. So you may identify these limitations through conversations with your supervisor, by reading policy statements, gathering information in meetings. So just based on your own understanding of the situation, you're the one that has to come up with what the constraints are. Even after you enter data into Solver and run a report, you may gain knowledge of other limitations that you might want to build into the model. You have to add it later on. So using the home loan example, a constraint might be that the down payment must be between $5,000 and $8,000. All right, so now you are ready to watch the tutorial video on the solver. Okay, loading solver and specifying objective and changing cells. That's all in the tutorial too, and adding the constraints to the solver. All right, so after you have solved with the solver, we create a solver report. So after defining the objective, changing variable cells and constraints, you select a solving method. The solver uses the selected solving method to determine which types of algorithms it executes to reach the objective. The three different solving methods are GRG, nonlinear, simplex, LP, and evolutionary. Look up solver and help to link to a specific set of descriptions to these methods if you are more interested in learning about these three specific methods. You can also review additional information and additional add-ins on www.solver.com. So if you need even more than what Solver provides. So for the purposes of this chapter and keeping it simple, we're going to accept the default option, GRG nonlinear. But just note that if you are interested in learning about the other two, the information is there. All right, so now you're ready to use Solver to find a solution to the problem, right? Solver uses an iterative process of using different combinations of values in the changing variable cells to identify the most optimum value for the objective cell. It starts with the current values and adjusts the values in accordance with the constraints. Once it finds the best solution given the parameters you set, it identifies the values for changing variable cells and shows you the optimum value in the objective value. So if Solver can't determine what an optimum value, it doesn't enable you to generate summary reports. Okay, so this is just basically a breakdown of how it actually works. Now let's look at the summary report. Okay, Solver creates a new worksheet for the Solver summary report containing 4 major sections. When you get the summary report, you'll notice the 4 major sections, and in the next slide I show you the 4 different sections. But first let's talk about it. The first section displays information about the Solver report. So specifically it displays the report type, the file name, worksheet containing the data set, date, time, the report was generated, Solver engine details, Solver options that were set at the time, and the time that the report was generated. So just kind of basically the metadata of the Solver report, okay, information about it. The remaining sections are the actual report that helps you analyze the results. So the section the second section displays objective cell information. So specifically, it shows the original and final objective cell values. For example, using the original worksheet values, the original total paid was $100,617.31, and the final minimized payment was $47,000 and a bit. Okay, and then we have the third section that shows the variable cells. Specifically, it shows the cell references, the variable cell names, original values, and final values. And then the final section shows the constraints. Again, so the second section shows the objective. The third section shows the variable, the changing. And then the final section shows the constraints. Like this. So the first section here shows all the details and information about the report here. And the second section here, this is the objective cell section, okay, and this is the variable, all right, and then you have the constraints as the last one. All right, so this sums up the Solver summary report.